Brightstorm has thousands of high-quality videos covering all major subjects. Please check out more at www.brightstorm.com.
Using the rational roots theorem to try to factor a polynomial. So I'm going to start out explaining this by looking at a fairly straightforward polynomial, x squared plus 6x plus 8 equals 0. In order to figure this out, we would want to factor our x squared plus 6x plus 8 and set it equal to 0 to find out what x is. Okay? This particular problem isn't all that hard. We would be looking at equal to 0. We know that our first two terms have to be x. Because both are positive, we know we are adding. And then when we're factoring this, we think about possible factors of 8 that go here and add up to 6. It could be 1 and 8, but when you think about that, we know that we would end up with a 9x here. Okay? So it leaves only the other options to be 2 and 4. Because the x's are singular, leaving us with 2 and 4. Order doesn't matter. Okay? So that's sort of the logic we go through when we factor a standard quadratic equation. Okay? And this tells us that x is equal to -2 or -4. Okay. What if we're dealing with a larger polynomial? Okay? Something of degree 3, 4, 5, so on and so forth, that we don't really know where to start factoring. Okay. So what I have here is a general form for a polynomial. Okay. When we first introduce polynomials, we always have these a sub n subscripts as the coefficient on a term of degree n or whatever it is. So here, a sub n minus 1 is the coefficient on x to the n minus 1. For this particular example, all I've done is I've changed my first coefficient to a p and my last constant term to a q. Everything else is exactly the same. Okay. And what the rational roots theorem says is that all potential factors, or all potential roots, all potential zeros, are of form factors of q over factors of p. And it could be either positive or negative. So when we're looking at that, the middle terms don't matter at all. Really, all we're concerned with are the factors of q, which is our last term, a constant term, over the factors of p, our first coefficient. Okay? And then we can either have positive or negative, any of those combinations. Okay, so that's the theorem in letters. Let's take a look at it in numbers. Okay, so moving down. I have a polynomial here. Okay, it's a fourth degree. First coefficient is 2. Last coefficient is 8. So what I'm looking for is the plus or minus factors of the last term over factors of the first term. Okay, so how I write this out is I just draw a giant fraction line, and then think about all the factors of the last term, factors of q. Okay, 1, 2, 4, and 8. That's the only thing that goes into 8. So this is going to be 1, 2, 4, and 8, plus and minus, over factors of the first term. In this case, our first term is just 2, so the only factors we have are 1 and 2. Okay, so we now have our weird fraction, and basically what this means is any combination of these numbers. So let's write these out. So we could have plus 1, or we could have minus 1, so that's the 1 over 1. We could have the 2 over 1, which would give us 2, or the negative 2 over 1, negative 2, and so on and so forth. Positive 4 over 1, negative 4 over 1, positive 8 over 1, negative 8 over 1. So here are some of our potential roots. We also then have to compare it to 2. Okay? So we could have positive 1/2, negative 1/2, if we compare the 1 and the 2. But then going down the row, 2 over 2 is just 1, which we already have listed here. 4 over 2, 2, which we already have listed. And 8 over 2 is 4, we already have listed. So those 3 over 2 are already excess. So these are the only potential roots for this particular polynomial. Okay? How we actually end up factoring this is a little bit more involved. We have to go into synthetic division and figure out which gives us a remainder of 0. But our list of numbers where we can actually start is a lot smaller. Okay? No longer are we just fumbling at numbers randomly. We have a list of a few select numbers we have to deal with. So using the rational roots theorem, factors of our last term over factors of the first term, is a really easy way to at least limit the number of roots we have to consider when factoring a larger polynomial.
By 2. I can't do this with you two laughing back there.
Work it. Work it.
So if we had, no, that's not right, 3 coplanar points.
So have you ever gotten off an airplane?
That should be less than. Yeah. Dang.
Is it like 500 degrees in here or what?
All right, so when you're in chemistry class, you're going to be doing a lot of work. You're going to be starting over.
So as an example, we could consider like you've got a chain hanging from two fixed.